Dr. Isloor was a professor and former head of department, chemistry department, National Institute of Technology, Surathkal, Karnataka. He had his postgraduate degree from Mangalore University in applied chemistry, and also his doctoral degree from the same university in medicinal chemistry. Now, his postdoctoral work was at Technion Israel Institute of Technology in 2005-2007. He has 19 years of teaching experience. Research interests are membrane technology, medicinal chemistry, organic electronics, etc., etc. He has published 270 scientific papers. There are three US patents awarded, and also one Indian patent awarded, and 6 are in the pipeline. He has written books. Given here are 3 books, like Advanced Nanomaterials for Membrane Synthesis and its Application in January 2019, published by Elsevier. He has guided 18 students to their doctoral degree. He is a visiting scientist at various universities in Malaysia, in Canada, etc. Now, he was selected as one of the 5 scientists by Scopus in 2014. And more interestingly, he was included within the top 2% of scientists at the world level in a survey conducted by the Stanford University of USA. Awarded C.V. Raman Young Scientist Award in 2018. In a lighter vein, regarding his hobbies, he writes popular scientific and technological articles, play keyboard, collects coins, and is also interested in gardening and cooking.
Thank you so much, Chairman sir. Just now we had an wonderful, mind-blowing talk by Professor Leleji, and let us move from the fantastic world of hydrogels and let's move into the something about polymeric membranes. It's my proud privilege to be here in this prestigious institution. I know the countdown has started, and also Professor Pradeep is also here. I will try to restrict my talk within the given time slot of 35 minutes. For the next few minutes, I will be talking about our little bit contribution which was given in the field of polymer membranes. And initial first 10 to 12 minutes, let us forget something chemistry and let us have some colorful pictures in the initial 10-15 minutes. And let me acknowledge Dr. Kavita and then Dr. Shaina, Dr. Sajeev and the entire chemistry department team for this invitation, as well as making wonderful arrangements over here. And of course, the director of NITK Surathkal for the wholehearted support and encouraging my research in NITK Surathkal. And of course, one of my collaborator, Professor Ahmed Fauzi Ismail. Presently, he is the Vice Chancellor in University Technology Malaysia. Since last 13 years, I am having a strong research collaboration with him. During the vacations, I visit his laboratory and we work together. Since last 12 years, we are working in the area of membranes. And of course, the fundings, the generous funding by Department of Atomic Energy, then DRDO, Department of Information Technology, Vision Group on Science and Technology, Government of Karnataka, as well as Ministry of Mines. Without their generous funding and the support, I would not have presented today's lecture. And of course, last but not the least, I give the credit to all my 18 research group members who already passed out their PhD from my group. So it's because of their contribution I'm here to present. And this is our beautiful green campus, NITK campus. Sorry. And you can see the Arabian Sea, which is dividing our campus into eastern side of the campus as well as western side of the campus. We have about 300 acres, and it is the NH66. It is dividing our campus into two parts. And many times our students have the fun activities on our own private sea beach. Yeah. Look at this handsome guy. I'm particularly interested in the perfectly stitched his trouser as well as his shirt. And the credit, it goes to a skilled tailor. I hope all of you agree with me. The skilled tailor, you know how they stitch such type of the fabric. First thing is, you may be knowing, you might have seen in any tailor shop. First, they design on the cloth and then cut into required dimensions and then stitch them together. Similarly, I can say that the job of an organic chemist is something like similar to that of a tailor. Because myself also, I am a basically organic chemist, so I strongly believe that I am like a tailor. But we play with the organic molecules. Rather than the fabrics, we play with the organic molecules. You can see here different small molecules. At the appropriate functionalities, we stitch them together and then we'll end up with the required larger molecule. Or it's like you can compare it to a trouser. So it's nothing but tailor-made polymers or tailor-made molecules, I can say. And let me introduce these two great personalities. One is Professor Surirajan, basically who is an Indian, basically from Chennai, and long back he migrated to University of Ottawa in Canada, and at the age of 99 he passed away. Last year only he passed away. And he was known as father of membrane technology. And another great personality, that is Professor Takashi Matsura, who is basically from Japan, who also migrated to University of Ottawa, and he worked along with Professor Surirajan, and they have immensely contributed in the area of membranes. So both these great professors, they are known as fathers of membrane technology, and I have the honor to work along with the Professor Matsura. As you know, in the hydrosphere, it's nothing but the total amount of the water which is present on this universe, where about 97% of the water is present in the form of the saline water in the oceans. And without the desalination, it is unfit for our consumption. And around 2% of water which is present in the polar regions in the form of the ice, and the water which we are using for our day-to-day activities, that is the fresh water or the potable quality water, the total amount of the potable water on this universe is less than 1%. And you know, because of the rapid urbanization as well as the industrialization, the demand for this potable water is increasing like anything. And many times between a sort of a conflict between our neighbors, maybe the people who are staying in the same apartment, or maybe in the same colonies, or maybe between the two different districts. So for example, between the Mangalore district as well as the Bangalore district. So there is a sort of conflict which is going on since last 8-10 years, even though it's within the same state of Karnataka. The reason is sharing of the Netravati water, or maybe between the two different states again, or maybe even at the international level, any such conflicts is because of the water only. So it's not only economically important, but politically also water is very, very important. And one of the best technology which is which I can recommend is that is nothing but the membrane technology, which is as of now most efficient and economical as of now in the present scenario. And these are some of the pictures which are self-explanatory. I don't want to give any more details on this. It shows the requirement as well as the importance of the water in our day-to-day activities. Maybe Professor Narayanan may be surprised to see this picture. How come such a sort of snowfall in southern state like Karnataka or in other places? So this is a picture which was taken from Bangalore. There is one region called, there is one lake. The lake has been contaminated to such an extent. Many times the froth which is formed in the lake, that is blocking the national highway. So, and then the other pictures, I'm not any brand ambassador for any of these water purifiers, please don't misunderstand. Again, in these type of the water purifiers, either in the residences or in the offices, these are also very common. Again, these are working based on the membranes only, either ultrafiltration, microfiltration, or the reverse osmosis, or the hybrid type of the system. And there is a solution effective solution is possible for this particular, the pollution of the river waters by membrane technology. Even the other picture where the fuel cell which is separated by anode as well as the cathode, and there is a anode and the cathode separated by a semi-permeable membrane. Again, the role of the membrane is, it's a heart of the fuel cell. Membrane is heart of fuel cell here. And even in the automobile sector, such filters which are common. Of course, the filters which are used in the automobile sector, they are hydrophobic type. But for the water purification, either in this one or here, or even the next one, which is a hemodialysis cartridge, where actually the hydrophilic type of the membranes which are required. So based on our requirement, either hydrophilic or hydrophobic, and by applying the knowledge of our synthetic chemistry, we can tune the properties of the polymeric membranes or polymeric materials. So this is a hemodialyzer, and this is basically the ultrafiltration membrane. So we are working on, right now we are at the clinical trial for the development of the low-cost hemodialysis cartridge. So if you ask me, what is membrane? In a very simple way, it's nothing but a barrier which allows the passage of the certain selective component, and at the same time, the unwanted components will be hindered by. So that is the simplest definition we can give for a membrane. It's like a barrier, or a selective, you can say a selective sieve also. And basically they have been, based on the pore size, they have been classified in the 4 categories. One is microfiltration, ultrafiltration, nanofiltration, as well as the reverse osmosis membrane. My lecture is mainly highlighting on the ultrafiltration based as well as the nanofiltration based membranes. You may ask me, already there are reverse osmosis membranes are there. It gives its efficiency to remove the salinity up to the 99.9%, then why other membranes are required, like the nanofiltration or the ultrafiltration? The basic thing is, of course, the efficiency wise it is giving 99.9% removal, but they are highly energy consuming. It requires about 30 to 60 bars of pressure for the operation of this RO filtration membranes. Whereas the nanofiltration membranes as well as the ultrafiltration membrane, they can be worked at a much lesser pressure. So these are the energy efficient. And the main challenges in these membranes is choosing an appropriate as well as stable polymeric material, and then minimizing or preventing the fouling. You might have seen in your residences, when the water purifiers are not functioning, then the the vendor will visit and he will replace the cartridge. That is nothing but after usage of these membranes for some particular time duration, maybe few months or sometime maybe few years, depending on what type of depends on the quality of the water which was fed into the system. The efficiency may drastically, it may come down. That is because the fine porous structure or the surface of the membrane, they gets deposited by the impurities or other, the growth of some algae may be possible. Thereby, the pores will be completely gets blocked and the filtration efficiency will be drastically, it will come down. That is known as fouling. So, all the membrane technologies, the major they are working on preventing as well as the minimizing of the fouling. And the application wise, the desalination, wastewater treatment, biomedical, pharmaceutical, dairy industry, in almost even in the electronic industry also, every aspect of our life, the membranes are highly useful. And the qualities of good membrane material, first thing is it should be film forming in nature, because there are hundreds of polymeric materials which are commercially available. All are not suitable for the membrane application because it requires certain criteria. The first thing is film forming nature, the mechanical strength to overcome the pressure during the performance. Any of those membranes, either microfiltration, ultrafiltration, nanofiltration, or that of the reverse osmosis, it works based on the applied pressure. So, when some pressure or the mechanical strength, when it is applied, strain when it is applied, it should be stable material. So, the mechanical strength to overcome the high pressure or any strain. And then thermal stability should be there, particularly while treatment of the wastewater, industrial wastewater treatment. The chemical stability also, and a proper, as Professor Ashish ji has mentioned, maintaining a proper balancing between hydrophilicity as well as the hydrophobicity. So that is also a great challenge here. And the most commonly used materials like polysulfone, polyether sulfone, PVDF, chitosan. So these are some 6-8 polymers commonly which are used by which have been most attracted by the scientists who are working in the field of membrane technology. And please believe me, none of these materials which I have showed, they are not satisfying all the properties. One or the other deficiencies are there. There comes the role of a chemist or a synthetic chemist, so we can improve the performance of those materials. These are the structures. I'll just, If you ask me how to prepare these membranes, generally two types of the membranes are there. One is a flat sheet membrane, which are popular since last 4 or 5 decades, just like a flat sheet, normal flat sheet membrane. And the preparation of such membrane is it's just like making the roti or chapatis. So you prepare a polymer solution with the required viscosity, and then cast it on we have an automated instrument where we can control the thickness of these membranes. Otherwise, for the beginners even, they can start with a normal glass plate and a casting knife. Just hardly one need to spend some 300 to 400 rupees, that's all. We have started our work in the NITK when I joined about 15 years back. I started with that. Now we have developed the sufficiently, most of the equipments which are required for this particular research. And after casting the solution, the polymeric solution, then remove the glass plate and immerse it in the distilled water. There actually the phase separation which will take place. So what happens is here, the solvent which is used for preparation of the polymeric solution, like generally we use organic solvents or like NMP or the DMS or DMF, those type of the solvents we use. So when we immerse the glass plate in the water, the solvent, that is the organic solvent which is used in the polymer solution, it tries to come outside the polymeric matrix. And the water molecules which tries to enter into the polymeric matrix. So during this particular phase separation, the membrane, it gets separated, and also there is a porosity will be also formed because of that. And then we have recently we have introduced in our laboratory hollow fiber fabrication system, because in the last 8-10 years the hollow fiber membranes are gaining more and more importance because of the efficiency wise. When you compare the hollow fibers and the flat sheet, the hollow fibers are found more superior. The lifespan is also superior, much higher than that of the flat sheet, and also the surface area is much larger as compared to the flat sheet membrane. Just I'll be running this particular slide, this video. Yeah, this was installed about 6 months back in NITK Surathkal. And initially we have to prepare a polymer dope solution, and then there is a spinneret which is the core of this fabricating system, and then this is the water. So once the polymer solution, once it dips into once it gets introduced in the water, it gets precipitated into the fibers, and these fibers are completely hollow, just like a normal tube. And then this is a wounding system. This is the polymer membrane. It will be collected on this particular drum. And we can adjust the speed of fabrication. So up to maximum of about 700 meters of these fibers we can cast we can spin in 1 hour. And this is the schematic diagram for the hollow fiber spinning system. Yeah, this is actually the one of the cross-sectional picture of the hollow fiber membrane, the scanning electron microscope picture. You can see it's a completely hollow structure. It's a completely hollow structure. The water or the solution or the fluid which is to be purified, so it will be introduced from one end of this side, and you can see on the surface these are the fine finger-like projection which are nothing but the microvoids. So through which the separation will be taking place, and these hollow fiber membranes, this can be operated in the 2 different ways. So one is the liquid which is to be purified, that can be introduced from in to out, which is called as in to out, or the another configuration is out to in. That means from the outer surface the impure liquid which will be introduced, and then the purified will be collected from here. So it can be operated in either in to out or from the out to in any one such modes. Of course, these are some other pictures. Yeah. Now let us look into some chemistry behind while fabricating these membranes, some of the chemistry. Of course, as I mentioned, the fouling is one of the major challenge to minimizing as well as the preventing of the fouling and increasing the efficiency of the polymeric membrane, which is the major challenge. And across the globe, many scientists and the technicians and the engineers who are trying to improve the performance of these materials by introducing different type of the nanomaterials. You can find at least few hundreds of publications, hundreds of papers where different type of the nanoparticles have been introduced into the polymeric matrix to improve the performance of these membranes. However, I always used to tell my group members, let us something different from others. Apply your organic synthesis and let us try to be something different. So I give the credit to one of my group member, Dr. Syed Ibrahim, currently who is doing his postdoc in University of Nebraska, Lincoln. He actually introduced the Zwitterionic polymer nanoparticle, and after that another couple of my group members are also working in the similar with the further improving the synthetic strategy. Let us see what are the in the conventional method of nanoparticle synthesis, as well as we have adopted already it's a reported one, the DPP method, which is nothing but the distillation precipitation polymerization. Let us see what are the difference between these two, conventional method as well as the DPP. In case of the conventional one, the preparation time period is a somewhat longer, and in most of the reported methods, in the conventional methods of the nanoparticle synthesis, it's longer, as well as the harsh conditions, difficult to disperse, the non-uniform size particles in many of the reported procedures, as well as the further modification. Suppose if you want to improve the performance of the material, you should find some functional group or the other molecule which you are going to introduce that should easily bind with those nanoparticles. So it's very difficult in the conventional method of the nanoparticle synthesis. Whereas in the distillation precipitation polymerization, this can be overcome by DPP. It doesn't require any highly sophisticated instruments or the glasswares. It's just a normal system only. Only thing you have to introduce the Dean and Stark apparatus, because during the reaction, the excess of the solvent which will be, once it get refluxed, so it has to be excess to be collected back. So that is the Dean and Stark apparatus that need to be connected to a glassware, and it has to be carried out. And all these, whatever the drawbacks which you have seen in the previous one, that can be, most of them can be overcome by the DPP. So we have adopted the DPP method for the synthesizing these Zwitterionic polymer nanoparticle. You may be asking again, what are these Zwitterionic polymer nanoparticles? Nanoparticles, as I said, hundreds or thousands of papers you can get. When it comes to the polymer nanoparticles, again, it filters to few limited papers. Then again, when you put the Zwitterionic materials, nothing but a molecule which is with both positive as well as the negative charge, still you can find the very few paper or very less work in this particular area. The advantage of this Zwitterionic nanoparticle is their dipole moment is very high, and since both charges are there, it's a polar molecule. It's like a polar. So by introducing such type of the material, we can improve the performance of membranes. And of course, these materials can find applications in the biomedical. Right now, we have not focused in that area, but these are highly potential for other applications too, rather than membranes. And this is the one such work. What we have done here is some Zwitterionic polymer nanoparticles which have synthesized by the DPP method, and these were incorporated into polymeric matrix, and then hollow fiber membranes were fabricated. These were done initially in my collaborator in UTM Malaysia, and then these membranes were used for the removal of the dyes which is present in the wastewater. So for the industrial, the wastewater from the industries, which is, if it is richer with the dye, so this is, I can suggest this is the one such fantastic material for the efficient removal, even up to about 97 to 98% of the dyes which were successfully we have removed. And the strategy which was employed in this particular the DPP, it was a very simple. So we have chosen two different type of the monomer. So one is a sulfobutane, we have named it as a SBMA, and the second one is it's a bisacrylamide. Here it is. The second one is the bisacrylamide, and the AIBN, as well as the solvent as a acetonitrile which was used. And on the DPP, that is distillation precipitation polymerization, this is the final the structure of the polymeric nanoparticle. And these nanoparticles, as I mentioned, these were incorporated into the polymeric matrix because these were used as additives to the extent of about 0.2, 0.3, 0.5% in the different ratio. These were purely used as additives into the polymers like a polysulfone as well as PVDF materials. And of course, the different characterization to confirm the formation of those Zwitterionic nanoparticles. And you can see the beautifully arranged finger-like projections, which are nothing but the microvoids in the hollow fiber membranes, and the presence of these materials, that is the Zwitterionic additives, it has significantly improved the performance. You can see the results in the next one. And this is actually the two different type of the dye solutions which I have prepared. One is RB5 as well as the RO16. In both the cases, it was about beyond 95-96% of the removal of this dye which has been observed. And of course, we have compared also with the other, the already reported as well as the commercial membranes, and our materials found to be more superior. And then again, many of the researchers, as you know, in last 10 years particularly, the graphene or the graphene oxide, many researchers who are working. Again, we wanted to improve the performance of these materials still to a higher extent. In this one, what the strategy we employed was, on the graphene oxide, these were synthesized separately in the laboratory. And then this graphene oxide, these were decorated with the Zwitterionic polymer nanoparticles. And as per our as we expected, the performance was much superior than that of the previous material. So this is the synthetic scheme for the preparation of the graphene oxide, which is decorated with this material, Zwitterionic nanoparticles. Of course, the different characterization, including the EDAX as well as the FESEM and also the XPS, all the required characterizations which were performed. You can see here, as compared to other already reported materials, this is found to be superior, more superior. And the dye removal efficiency was also, this is around, in one of the dye, it was about almost 98%, 98, 99%, whereas in the another one, it is found to be about 74%, 74 to 75%. It's mainly because of the size of these materials, the dye molecules, as well as what type of the pH which is maintained during the purification. This is the schematic representation for the hydration of the dye molecules. So when this dye molecule, when they interact with the water molecules, so they form the much larger clusters at a particular pH which you have maintained, and these are the structures of two different dye molecules which were employed for this particular task. Of course, the anti-fouling also, those studies were also performed. And this is the material you can observe. This material is much superior as compared to the already other reported few of the patents. Then again, some other modifications we wanted to do. As a scientist, we cannot keep quiet. So once you get a material, then we'll try to improve the performance, or we'll try to make it more economical, or the synthetic step we try to minimize or to reduce. So that is what the further continuation. In this one, actually, this material, the amino acid, that is cysteine, which was employed here. You can see here. Of course, the monomers which were used are different from that of the previous. And then once these Zwitterionic materials were prepared, synthesized, then this is reacted with the L-cysteine, that is the amino acid, and this is the cysteine which is decorated by the cysteine molecule, amino acid modified by the Zwitterionic nanoparticles. Again, all these characterizations. Let me focus on our recent published work. Just about 3-4 months back it was reported, where actually this is a novel strategy which we have introduced for preparing for the synthesis of ionic polymers. Of course, ionic polymers, these have been reported, but our strategy is in the synthesis. the reported strategies, so they have, after synthesizing the polymer, they have quaternized that, or in the starting itself, they have used the ionic type of the monomers, and just like the Zwitterionic which we have reported earlier, where actually we have used the ionic type of the monomers. Or the quaternization can be done after synthesizing the polymer material also. But in this one, we have changed we have developed a new strategy, a new methodology itself for this QPP method, that is quaternization, precipitation, polymerization method. You can see the monomers, this is the monomer, and the other two monomers are the nitrogen based, two different monomers, and upon QPP, so this has resulted in two different type of the polymers, and these polymers are with the ionic polymers only. The strategy is entirely different. We have not used the charged particles as a monomers, but during the process itself, this is a different. So these materials, these were introduced as additives into the polymeric matrix. And all the required characterization, and even we have filed the Indian patent last year, and after that only we went for the publication of this particular work. And these were used for fabrication of the flat sheet membrane rather than hollow fiber membrane. We wanted to say in what way we can improve the performance of the flat sheet membrane. And these membranes, a fantastic material for the separation of the oil which is dispersed in the water. Because this is a major challenge, you may be knowing, when there is a oil spillage in the oceans, the removal of that is of course different methods, different techniques are there already, like the adsorption or flocculation, different techniques are there. But this is the membrane based materials with these type of the ionic polymers as additives. These showed a excellent material for the separation of the oil which is present in the water. Let's go to quickly move to that those work. Different type of the oil like, different oil like the kerosene or the diesel or the hexane and the different other solvents were used. You can see the emulsion, these are the emulsion, and this is the pure permeate, that means after the filtration. So this is the actual one after the filtration. These were the in the form of the emulsion, which are containing the like the diesel in water or the hexane in water, the toluene in the water. So these are the different oils which we have used for this particular study. Finally, I can conclude that the tailor-made Zwitterionic polymer nanoparticles, these are the excellent materials for improving the performance of membranes. And then DPP is one of the best method for synthesizing this Zwitterionic polymer nanoparticle, and also the QPP, which is another strategy which we have introduced. So that is also, no doubt, that will also gain a significant importance in the coming days. That's all, some references, and thanks for this particular opportunity. I think I have completed on time, so thank you. This is the last picture which I have taken in Israel, the Dead Sea of Israel. The speciality is, even though if you don't know the swimming, you can easily float on the water. So it's the Dead Sea. It is not a sea actually, it's a lake which is distributed between the Jordan, Palestine as well as the Israel. So that was my dream since my childhood days. I wanted to visit Israel only to float on this water on the Dead Sea. So that has ultimately, it became reality during 2005 when I landed there for doing my postdoc. Thank you.
Thank you, Dr. Arun Isloor, for your erudite lecture on membrane using water purification, the water, the Amrit on earth. Thank you.
Thanks. Okay. Okay, sir. Thank you, sir. It's been a pleasure.
No, I just wanted to check whether there are questions from students.
Thank you, sir, for the informative talk.
Thanks.
I have a couple of questions. You have talked about the non-solvent induced phase separation method for the preparation of membrane.
Flat sheet membrane, yeah.
Yes. How can we control the pore size of the membrane?
Yes.
Also, another question is, we are getting, the strength of the membrane is less when compared to other techniques. How can we improve the strength of the membrane also?
The first one is regarding the porosity.
Yes.
Of course, different type of the factors, like what viscosity which you are maintaining, and
Okay.
then what type of the additives are added,
Okay.
and when you are immersing it in the water or the bath which is containing the water, so you can add there also different type of the other solvents like ethanol or acetone. So different factors are there. So you can accordingly you can modify the porosity, and also humidity is also making a lot of difference in the porosity. So if you can keep the glass plate where the polymer solution casted glass plate, if you can keep it in the humidity chamber, you can have the more pores. The porosity will be much higher.
Okay.
So different such factors are there. And the second question is regarding the stability.
Sure.
Stability is again when you add other composite materials, because it's not just only one type of the polymer. We also add the other additives or the other materials. Thereby we can give the mechanical strength. And another strategy which is used is particularly in the commercially available flat sheet membrane. It's in the form of non-woven supports. Non-woven supports are which are available. These are actually acting like just a mechanical support, the non-woven supports which are commercially available, on which you will be introducing the polymeric solution as a membrane. So the polymeric solution or that membrane that actually acts like a filtration through them, and the non-woven support is like a for the mechanical support.
Whether the non-woven fabric that reduce the permeability and selectivity of the membrane, whether it is reduced,
Excuse me?
we are giving a support, whether it reduce the permeability and the selectivity of the
No,
membrane.
it cannot reduce because the non-woven support it's a highly porous structure.
Yes.
It's a highly porous structure. Even the pores will be much larger than this any cotton fabric.
Yes.
It is the role is just like to give a mechanical support.
Okay.
It's a just mechanical support. The actual filtration that will be through the is polymeric layer.
Okay.
And even in the polymer, this membrane also you might have observed on the top layer where actually the selective filtration which will take place. And the later the finger-like projection through which the percolation or the mobility of the water which will take place.
Okay.
Actual filtration is at the top layer.
Top layer.
Suppose if this application is for the gas separation, we are also working on the enrichment of oxygen or the separation of the gases, where the membrane porosity should be highly dense.
Okay.
It's a highly dense. It should be like a non-porous, almost like a non-porous. So depending on the application, for what application we are using, we have to change our strategies also.
Okay. Okay. Thank you, sir.
Yeah. Okay. So once again, thank you so much for this wonderful opportunity. Thanks.